Hello and welcome to the data structures using Java series. In this video, we will be discussing how we can traverse the single linked list. In the previous two lectures, we saw that how we can insert a node at the start of the linked list, and then we saw that how we can insert the node at the end of the linked list. Now we will be discussing how we can print the data present in your linked list. So what I did is basically I took the linked list which contains the 4 node, that is 6, 2, 4 and 1. And initially we have as usual head pointer which is pointing to your first node of the linked list. So what I need to do is I simply need to print all the data present in your linked list. So how we can do is, the first and most important point to note over here is that, as we already discussed 3 to 4 times, that never change the position of head. But we know that the head is going to give us the starting point of your list. So this is our go through of traversing the linked list, right? So what I'm going to do is simply I'm going to take a temporary pointer which is nothing but as temp, and I will be initializing with the head. So temp will be pointing to my first node, and my output should like a 6, 2, 4 and 1. So this is how I should have the output after traversing the whole linked list. Okay, initially I'm at 6, so I simply printed the 6. So how can I print the 6? If my temp is pointing to this node, how can I print the 6? So as we discussed during our third lecture, how we can access the members of the node. So simply can I write like this, as it is nothing but temp.data, right? Temp.data simply gives us the data of that particular node for which the temp is pointing. Similarly for 2 you can have the temp.data, temp.data, temp.data. But before we do the temp of data for the 2, you need to reach at 2, right? You need to reach at 2, and in order to reach at 2, the node which contains a 6 contains the address of the next node which is nothing but 300, right? So simply what I need to do is I need to do temp is equals to temp of next, right? Temp.next. So initially my temp contains point to this node. So if I do temp.next which is 300, so my temp will be shifted to my second node, and this will get simply erased. Now what I will do is, right now I'm pointing to 2, so now I will do come at 2 and I will simply do a temp of data. So simply 2 will get printed. Now again I will come at over here, so temp which is initially pointing to 300, it will get replaced with the next address, which is my next address 500. So temp.next, so temp will move to the next point, that is nothing but 500, and this temp will simply get erased. So again I am pointing to 4, so I will do the temp of data. So I don't know how many nodes are present in your list. So as discussed in the previous lecture, we need to make use of a while loop, right? So while temp, I don't know what the condition should be. In the previous lecture, if you observe carefully, that in the previous lecture we saw that we need to stop when temp.next equals to null. But while traversing, if I do temp.next equals to null, what will happen? Let's suppose I'm initially pointing to my last node now, and what I did is temp.next equals to null. Yes, you did, yes, and you might not get print this element, right? So what I need to do is I need to keep on going until unless my temp is not equals to null. Now what will happen? Now let's suppose you are present at the last node, and then I came at this point. What will happen? Temp is not equal to null. Yes, temp is not equal to null because temp is pointing to 200. Right? So you are simply moving ahead. Now what will happen? Instead of this, if I write, let's suppose instead of this, if I write temp.next is not equals to null, and now you are pointing to my last node, and you came here and say temp.next is not equal to null, but it is equals to null. So condition will get false, and you will ignore this node, right? But we don't want to ignore this node. That is the reason why I wrote temp is not equals to null, and simply I can move this ahead. But before I move ahead, don't I need to print the element present at that node, right? Let's suppose if I am pointing towards 6, before I move to the 2, I need to print the 6, right? So what I will do is I'll simply do here println temp of data, right? This is what we wrote, and then I need to move my temp to this next location, that is nothing but temp.next. and this is how we can basically traverse the list. So what we are doing is we are moving from one node to another node till my temp is not equal to null. If your temp is equals to null, which means you are moving beyond the last node, so any of this condition will get false. And now once you come inside the loop, first of all print the data for which you are pointing to. Let's suppose if I am pointing to 6, first print the 6 and then move ahead, first print the 2 and then move ahead, first print the 4 and then move ahead, first print the 1 and then go out of your list, right? So this is how we can use to traverse the list. But again, what if your list is empty? Your list is empty, which means again by default, if your head is pointing to null, right? If your head is pointing to null, which means your list is empty. So simply I can print the message as empty. I can simply print it as empty, and simply I can return because there is nothing to print it. Otherwise, if your list is not empty, inside the else part you can write all the code what we wrote here. So I hope so that you came to know that how we can traverse the list. So let's move on to the IDE and check how we can write the code for this. So basically what we did is, first of all we inserted the node at the start, and then we inserted node at the end, and here we wrote the code, right? This is the code to insert a node at the start, and then we wrote the code to insert a node at the end. And now again here I will be writing the code to traverse the list. So what I can do is, so I will simply write as public void traverse, right? No data we need to take because we are not going to add a node, we are going to print the node. So what I will do is, again first of all I will check if my list is empty or not. So if my head is pointing to a null, which means my list is empty, so I'll simply print the message as list is empty, right? And then I'm going to simply return it. Otherwise what I need to do is, otherwise I will create a temporary node which is pointing to a head, and then I will keep on moving this till my temp is not equals to null. Temp is not equals to null, keep on moving it, and simply I need to do temp dot next. But before I move my temp to the next node, what I need to do is I need to print the data of that node. So simply what I will do is I will print the data. So I'll do temp dot data, and simply I will add a space in between them. So this is a simple code which we can use to traverse the list. Let's check out. In the previous two lecture I inserted the two nodes. First I inserted 10 at the start, and then I inserted 100 at the last. Let's check whether we are able to traverse this list or not. So what I'll do is I'll simply call in.traverse. If I run the code, see, we inserted 10 at the first, and then I inserted 100 at the last. Let's suppose I insert one more node at the last. Let's suppose insert at end, and I inserted as 900. So it should come as 10, 100, 900. Let's check. Yes, we got 10, 100 and 900. Let's suppose I insert one more node at the start, that is list dot insert at start, and I inserted as 1, and it should come as 1, 10, 100 and 900. So this is how we saw the three ways to implement the linked list. First we saw how we can insert a node at the start, then we saw how we can insert a node at the end, and finally we saw how we can traverse the list to print the data present in your linked list. Just in case if you are new to our channel, do subscribe the channel for more such videos.